All right, boys and girls, here we are. We have hit the chapter 18, two-dimensional shapes unit. Oh, I love these. These are so much fun. Okay, we're going to do all the practice one in this video if we have time. Otherwise, I may need to split it into two videos, okay? All right, practice one, classifying polygons. Circle the polygons. All right, a polygon. I'm going to come over here to this kiddo here with glasses, and it says, a polygon is a blank figure formed by blank or more line segments. So I'm looking at these. I see some that are open, like this isn't closed, right? It's open. So a polygon is a closed figure formed by three or more line segments. So a triangle could be a polygon, okay? Three or more line segments, meaning that we can close it, okay? So if you circle all the ones that are closed and they're made up of three or more line segments, you got it. Let's come on down here. 2 and 3 it says mark the angles, label the parts of each polygon. So for all of the angles, you can just kind of make a little circular line here, okay? Kind of like that. Or on this one over here, those are all of the different angles, and they're on the inside from going from one line segment to the next. That is part of an angle, okay? This part of the angle, or part of the thing, is the line segment, okay? And the fancy name for that corner thing is called the vertex. Okay, V-E-R-T-E-X. And if you have more than one, you would have vertices. Okay? Okay, here we go. That was 2 and 3. Numbers 4, 5, 6, 7, 8, and 9. It says identify each polygon. Now, I'm a little bit confused here. 4 and 5 look very, very similar. But if you look closely, 4 is technically a rectangle. Okay? So 4 is a rectangle. And 7 is a square, okay? 5 has 5 sides, therefore it is the pentagon. 6 has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's octagon, kind of like an octopus has 8 arms. Well, this has 8 sides. Number 7 we said is a square. Number 8, that is the hexagon. 6-sided hexa. So that's your 6-sided shape there. And we have the last one. That's the old red trapezoid here. Let me move the screen over just a pinch so you can see all of it. There we go. If you remember back, this is one of my favorites to do when I taught kindergarten. I loved using these blocks. So all of these different things, right? We had all this fun stuff, and a lot of people would build special things like this. You guys would always do such a nice job. Anyway, here we go. That is the trapezoid. So 10, it says polygons, square, octagon, hexagon, triangle, rectangle, pentagon, parallelogram, rhombus, and trapezoid. And whoops, we also have number of sides, number of vertices, and number of angles. So let's just look at that square, okay? And the square, number of sides, 1, 2, 3, 4. Number of vertices, that's how many corners, right? 1, 2, 3, 4. Number of angles, 1, 2, 3, 4. Okay, I'm going to skip the octagon for a second because I have a hexagon, so I'm going to use that one right now. Again, number of sides, 1, 2, 3, 4, 5, 6. Number of vertices, 1, 2, 3, 4, 5, 6. Number of angles, 1, 2, 3, 4, 5, 6. All right, let's skip now to the triangle. Oh, I don't know where my triangle is. Where'd that little rascal go? Well, we're just going to kind of move on, and I'm going to use half of this. So I'm going to pretend that you only get half of that right there. So you get just the blue part. Okay, there's your triangle. So, number of sides, 1, 2, 3. We have number of vertices, 1, 2, 3. Number of angles, 1, 2, 3. Hee. So on and so forth. So you're going to notice every single one of these has the same exact number. So 1, 2, 3, 4 sides, 1, 2, 3, 4 angles, 1, 2, 3, 4 vertices. Every single one, the answers for sides and vertices and angles are going to be the same. Okay? Even for the red trapezoid. 1, 2, 3, 4 sides, 1, 2, 3, 4 vertices, 1, 2, 3, 4 angles. Which figures have the same number of sides, vertices, and angles? Every single figure you did up here has the same exact number of sides, vertices, and angles. But it's not asking you that. It's asking you which one. So like rectangle has 4, 4, and 4, right? Parallelogram, 4, 4, and 4. Rhombus, 4, 4, and 4. Trapezoid, 4, 4, and 4. So those would be your answers there. A square, rectangle, parallelogram, rhombus, and trapezoid are some special polygons. They have 4 sides, vertices, and angles. All right, 12. Are these statements correct, true, or false? So, I'm just going to put those out here so we can see them if we need them. Okay? A hexagon has 7 sides and 6 angles. That is false. Okay? A hexagon has 6 sides and angles. 13. All polygons have 4 sides. No, that is false. Polygon, 3 or more sides, so it could be a triangle, it could be more. 14. All parallelograms, squares, and trapezoids have 4 angles. That is true. 4 angles, 4 angles, 4 angles. Okay? 15. An octagon has 8 vertices and 7 sides. Wrong. 8 vertices and 8 sides. 16. A pentagon has 6 angles. No, it has 5. Penta, 5. 5, 5, and 5. A triangle has 2 vertices. No, that's false. It has 3. Number 18. A parallelogram can be separated into 4 triangles. That is true. Okay, a parallelogram. See if I can do that. Can I do it on there? No, I can't quite make my parallelogram out of that, can I? Oh, I need more than that number of pieces. But I'll draw a picture here for you, okay? 19, a rectangle has 4 right angles. That is true. So let's look at this again. And let's just check out our parallelogram. You know what? Let's come up over here. Parallelogram right there, okay? Something like that. So there's the triangle there. There's the triangle there. And there's the triangles there. So 1, 2, 3, 4 triangles. Okay? All right. All the way down here. Cut out the tangram below and complete the table. Well, I can't really cut that out. So you're going to have to kind of just do your best on that one as far as what you see for the polygons. I mean, we can kind of look like that's a triangle, right? 3 sides, 3 angles, 3 vertices. Again, another triangle, another triangle, another triangle. So you got 1, 2, 3, 4, 5 triangles. You have this one here. That's your parallelogram, right? That was just like what we did right there. And that would have 4 sides, 4 angles, 4 vertices. And then we have a rectangle. And that is also 4 sides, 4 angles, 4 vertices. So kind of polygon. Triangle, number of polygons, 1, 2, 3, 4, 5. And one was a rectangle, one was a parallelogram. All right. Use at least 5 polygons to make a figure. Complete the table. So you can put together 5 of them and see what you can come up with as far as what you can make. All right. Number 23. I am a polygon. I have 1 more angle than a rectangle. So rectangles have 4. So if I have 5 of something, that would be the pentagon. Okay. 24. I am a polygon. I have 1 more side than a pentagon. So I know we just did pentagon was 5. So what's the 6-sided one again? Doodle-doo. That's right. Hexagon. I am a polygon. I have 1 more vertex than a triangle has. What am I? Wow. Whew. Got a lot of options here, right? Would this one count? Yeah. Would this one count? Yep. How about this one? Yeah. How about this one? Uh-huh. You could still also use a rectangle. We didn't have a rectangle on there. That could be another one. A lot of options there. All right. Add one more polygon to the shape below to make it a hexagon. So it kind of looks like this. Let me go like that. Like one there, and it comes out like that. So right now we have 1, 2, 3, 4, 5 sides. So we would want to take one of those sides, right, and turn it into 2, because that would make it 6 like a hexagon. So if you took, say, one of those triangle pieces, you could put it out like that, and that would make it 1, 2, 3, 4, 5, 6. That'd make it a hexagon. All right. Identify each quadrilateral, then explain your answer. Example, here's a rectangle, 2 pairs of opposite sides that are parallel. Only the opposite sides of a rectangle need to be of equal length. All 4 angles of a rectangle are right angles. Okay, the first one is the parallelogram. The parallelogram, both opposite sides are parallel. That's where it gets its name, parallelogram. So these are parallel, these are parallel. Okay, these will be the same length, and those will be the same length. And it has 4 angles, 4 sides, 4 vertices, stuff like that. This is a rhombus. All 4 sides of the rhombus are the same length. It has 4 angles, and the opposite sides are parallel. So this line segment and this line segment are parallel. This line segment and that line segment are parallel, and all 4 are the same length. Here we have a trapezoid. I know we're used to seeing a trapezoid look like that, right? But the definition for the trapezoid is that only one set of lines, segments are parallel. So these 2 sides are not going to be parallel. It could be flat, and it could be angled. Either way will work for that. Okay? It could have up to 2 right angles. Okay, here we go. 30. We're going to write P for parallelogram, R for rhombus, or T for trapezoid. This is not a parallelogram, a rhombus, or a trapezoid. This is a parallelogram. It looks just like the one above, right? And opposite sides are parallel. Right here, opposite sides are parallel, right? 4 angles, all that, those 2 are the same, okay? Here we have, that is the trapezoid, and we knew that one. Here we go. This is a parallelogram. Opposite sides are parallel, right? But it's also a rhombus. All 4 sides are the same length. That's really a couple different ones. And here, there we go. We got their trapezoid on that one as well. Okay. How is a trapezoid different from a parallelogram? So the trapezoid has one set of sides that are parallel. Parallelogram, both ends are parallel. Okay. How is a trapezoid similar to a parallelogram? Well, they're both polygons, right? They both have 4 sides, 4 angles, 4 vertices, and they both have at least one side that is parallel. All right, boys and girls, we made it in under the allotted amount of time, so woohoo for that. Hope you have a great one. Any questions, please feel free to get a hold of me, okay? All right, talk to you later. Bye.